I am Marta Casadesus, project manager at AI Textiles, and I will introduce you to the general trends in the technical textile sector. This content has been developed by AI Textiles in the framework of DESTEX project. Currently, the research in the textile fibers focuses mainly on finding materials that meet technical needs in various sectors. This involves the development of very specific fibers, fabrics, and finishing processes using technology to meet customer demands. The present lecture aims to give a general overview of trends in technical textiles, explaining the main research lines in materials, structures, and finishing treatments, and the key challenges for the textile technology. These are the knowledge and competencies you will take out of this lecture. The global trend of using technical textiles is increasing year by year. New and improved applications of technical textiles can project to propel its demand across various end-use industries. Nevertheless, it is important to mention that other sectors like security forces, firefighters, or foundry workers, for example, depend on technical textiles, so its demand is unlikely to decrease. The common trends of innovation in technical textiles in terms of concept can be stated as the dynamism at the level of product development to respond to new market pull demands or to replace other materials in analogous functions, the multiplicity of possible for the selection of materials, structure, product manufacturing, and their adaptation to very diverse uses, the substitution of conventional raw materials for new materials of high cost and performance. Technology used in technical textiles production is mostly alike to the regular textile manufacturing processes in terms of equipment, except for certain products. The main difference remains in the level of requirements and the quality of the final product demanded. The product's innovation cycle differs between traditional textile and technical textile sectors. In the conventional sector, technologically, new materials and processes can open new possibilities and make new products possible, which leads to an also new end users. The strategy is based on the demand. Nevertheless, in technical textiles, technology is at the service of the needs of the customer who's looking for a specific product that satisfies the needs of a specific end user. Let's explain now some of the main research lines in materials, structures, and finishing treatments. Different technologies used today in the textile industry can be arranged in stages of maturity chart, like the one you can see in the image, depending on their technological growth and their development level. High-tech fibers are already maturing, aramides, polyether ketones, PBI, etc., while others, for example, PBO, are growing along with ecological fibers or digital printing, due to the increasing collective sensitivity towards energy conservation and ecology aspects. Nanotechnology, plasma, or electrospinning are in an embryonic phase, while conventional technologies are declining. You can find more information in the document. Research lines in materials fibers. Fibers and yarns production is an integral part of the textile and garment industries. To stay competitive, these industries are striving for continuous improvement and therefore are constantly looking for innovative solutions to meet the changing demands and industry standards. These standards are geared mainly towards sustainable solutions such as recycling, waste reduction, production efficiency, and closed loop production. It is also important to highlight the introduction of graphene as a new material to the textile sector, opening a new wide range of possibilities. If you want to know more about this topic, please have a look at the document. Research lines in textile structures. Here we will speak about the new fabrics manufacturing technologies. It's not all only about chemistry. Also, by changing the structure of the fabrics, they can be used for different and specific applications. This can be done thanks to the development of new weaving and knitting equipment in order to make more resistant composites, 3D structures, or seamless products, among others. Research lines in functionalization treatments. Plasma. Plasma is an environmentally and worker-friendly method to achieve surface alteration without modifying the bulk properties of the textile substrate. Plasma technology is replacing numerous conventional wet chemical methods in laboratories and industries, which provides a solution to reduce the use of chemicals, water, and energy. It can be used in biomedical applications, functionalization of textiles, microelectronics, and medical fields. Lines of research are, for example, anti-aging of wool, treatment prior to dyeing to improve dye absorption. This technology still requires remarkable research effort. For this reason, the costs of its implementation are high. Research lines in functionalization treatments. Nanotechnology. The term nanofiber is used to define fibers which diameter is less than 0.5 microns, which are made through electrospinning processes. These nanofibers have a large surface area per unit mass and a very small pore size, and this means that their main applications can include, among others, filtration, protective clothing, nanocomposites, or drug release mechanisms. Some of the research lines in this area are microencapsulation of natural antimicrobial products, reducing toxic biocides, drug microencapsulation in medical textiles, among others. Research lines in functionalization treatments, electrospinning. Electrospinning is a process in which small diameter fibers, the microfibers already mentioned, are obtained from a polymer dissolved in an electrically charged solution as a result of the application of an electronic field between the two electrodes. The main lines of research in this area are scale up to large volumes, precision and reproducibility during the whole manufacturing process, and safety and environmental aspects. Research lines in finishing processes. Regarding the finishing processes, dyeing will keep its important and traditional role. Although this will be slightly affected by innovation with the mentioned technologies due to environmental aspects. On the other hand, the still growing technologies of surface finishing through plasma technology or digital printing can quickly reach a stadium of maturity without becoming real substitutes to the current technologies, but rather occupying a complementary role to the technological and economic reasons. Textile technology is an enabled technology for numerous fields and can make important contributions to new solutions for effective and affordable health care, highly functional sportswear, and goods and smart personal protection. Key challenges in the medical sector. Development of controlled release fiber, textile structure for therapeutics of different skin conditions, development of garments and home textile products with fully integrated biomonitoring, development of fiber and textile structures with enhanced thermal, breathability, electroactive properties. Key challenges in the automotive and aeronautics sector. Integration of fully integrated and printed electroactive and interactive sensors and actuators that enable the development of ubiquitous sensing and interactive surfaces. Integration of fully customizable self-lighting materials. Integration of programmable textile matrices for interactive sensing. Light and resistant structure with PTFA membrane for architecture. And separating tissues for growing vegetables. Key challenges in the sports sector. Development of lightweight performance garments, controlled drug release for muscle care, integration of low-power autonomous biomonitoring and or integrated communication systems for training monitoring. Key challenges in the personal protection sector. The integration of geo-tracking and personal GPS systems with all data monitoring systems sharing data in real time. Integration of cooling heating systems into garments. Key challenges in building and living. Development of new functional textile materials using nanomaterials and industrial waste eco-friendly technologies. Focus on high thermal performance. Adding sensors, communication systems in order to maximize comfort. Develop interoperability between connected devices. And thank you for your attention. I hope you learned a lot during this lecture. You can download the presentation to continue deepening your knowledge about textile innovation opportunities. Hope to see you in the next lectures.